Let's do some review for the vector quiz. Really, all these questions are on there. There's just not this many of each kind. There's quite a few questions that involve component form. So remember, that is probably the most important part. So we have vector P, tail, head. What's the component form? So component form, remember, is head minus tail. So we have to do -3 minus 4. And then for the y values, 1 minus 8. So the component form here is -7, -7. Absolute value bars means magnitude, so we're going to do the square root of 7 squared and 7 squared. And so that is the square root of 98, which this is kind of silly because we know this is 49 times 2, so this is 7 square root of 2. Be careful, don't do -7 squared like that in your calculator. Drop that plus, that minus sign, and just put it in as 7 squared so that your calculator does it correctly. Now to graph this, the tail is at 4, 8. The tail is the endpoint. So there's 4, 8, and the head is at -3, 1. -3, 1. So the direction obviously matters, the location of where the arrow is matters, and that's the graph. Now for this, to see if vectors are equal, the components need to be exactly the same. Now while these are the same numbers, they don't have the same sign, so these are not equal, and the reason is that the components are not equal. You don't have to get into great detail. They either are or they are not the exact same. There's 2 questions like 3, 4, and 5 on the quiz. Symbolically, obviously, is with the numbers. Geometrically is with the pictures. So for s plus t, it just says add s and t. That's a little bit awkward. I promise I'll put the s plus t on the test. So we're going to have 2 plus -5, so that's going to be -3, and 5 plus -3 is going to be a 2. So that's where the answer should go. Your first vector gets drawn in standard position, which is from 0, 0. When you're adding, the order doesn't matter, but I'm going to do s and then t. So vector s is right 2 up 5. It's a 6. Right 2 up 5. That's hard to see. So there's vector s. Label as you go. Now we're going to add to that vector t. So this is left 5 from this arrowhead, 1, 2, 3, 4, 5, and down 3. And so that is t. And then of course the resultant, close this up, and that is vector s plus vector t. And you'll see that those 2 arrowheads do point at -3, 2, so we're good. Now for number 4, this is subtracting. So we're going to find vector v. Make sure you pay attention to the order. So -1, 7 minus 3, -5. When you subtract, it's probably easier to add the opposite. So when we do that, we get -4 and 12. So the same thing is true when you graph it. We're going to graph the opposite one. So we're going to graph this guy, not the original. So when you're doing the opposite of a vector, make sure you change the signs. So again, now the order matters. So we have to graph vector v first. So from 0, 0, -1, 7. This is vector v. Sometimes I like to label it last because I'm not really sure how the triangle is going to go. For the next one then, we're going to do the opposites. We're going to go left 3 and up 5. And so there's your opposite of vector w. And then of course you close this up. This is a difficult looking triangle. And so this is the resultant, which is vector v minus vector w. And it does seem like it points at -4, 12. The graph is kind of hard to read there. Now, if you have a scalar, we just stack them up. So it won't be like this on the test. It'll be a combination of these three. So the scalar will be involved in another problem. So it'll be 3 times vector u, which is negative 2, 3. It looks like distributive property. It is distributive property. So the numbers are negative 6, 9. Now when you graph this, you want it to look like, it's very obvious you have 3 of these vector u's. So they will be stacked up. So we start at 0, 0, negative 2, 3. There's one vector u. Then you go left 2, up 3 again. There's another vector u, and then you go left 2, up 3 again. There's your third vector u. So the final answer is pointing at that spot, but it does look like there's 3, and they should form a straight line when you're using a scalar. Other magnitude and direction. I like to just count the squares to get to the graph, for the component form rather. Make sure you go x first, then y. That's obviously important. So this went right, looks like 4, and then down 6. So that's the easiest way to get to your component form. Remember, you want component form first. So we're going to go the square root of 16 plus 36, which is the square root of 52, which is 4 times 13. So this is 2 radical 13. Then your angle, inverse tangent, always, b over a. So negative 6 over 4. Now, if you think about what this looks like, if you think about this vector right here, if we were to just graph that, right 4 down 6, we're in the 4th quadrant. So we're probably going to have a negative angle. And when you put it in the calculator, the negative angle is okay. We do not need to move this. So it's negative 56.3, let's call that 10. 7, we already have component form, but we need to know where it's going to be located for the angle. So if we go left 3 and up 5, we're in the 2nd quadrant. So we're going to have to adjust the angle. But the magnitude is no problem. 3 squared and 5 squared. So this is the square root of 34, which doesn't simplify. And then we're going to do the inverse tangent of b over a. And when you put that in your calculator, you get a negative angle. So then we have to add 180 to that so that you can put it into the 2nd quadrant. So make sure your answer is between 90 and 180. This is 120.964 degrees. Number 8 is on the test. It is multiple choice. So the smart way to do multiple choice is just to do part of it and then see if you have the answer. So remember, this is going to be the magnitude times the cosine of the angle, then the magnitude times the sine of the angle. This is multiplying, right? We're going to multiply these two things together. Just put that in the calculator. It is component form, so we get negative 8.667. It says 3 decimal places, and then negative 5, which is a whole number. All of these are on the quiz. The whole rest of this page, actually this whole page is on the quiz. Here we're going to use imaginaries. When you do argument and absolute value of imaginaries, you don't use the I. Drop the I, but everything else is the same. That's why we do this at the same time as vectors, because we're going to do inverse tangent of b over a. Now, it might be smart. You have to graph it anyway. Let's graph it first so we know what quadrant we're in. So on the real axis, we go 4, and then on the imaginary axis, we go 3. So it's right 4, down 3, just like it would normally be. So we're in the 4th quadrant. So we're going to have a negative angle, and we get negative 36.87 degrees. For the absolute value, the square root of b squared plus a squared. Do not use the I. I squared is negative 1. It's going to mess up the whole number. So we have the square root of 16 plus 9, which is a plain old 5. The next 3, please pay attention to the order Also, when you put these in your calculator, I'll remind you this on test day, but the mode needs to be A plus BI so that you have permission to do that. Your calculator super likes the parentheses, so I would suggest using them. Sometimes it doesn't matter, but you're not going to know, so I would use them all the time. So I would put this in the calculator, -3 plus 2i minus 4 plus I. The calculator does a nice job of putting this in the correct order. Real, then imaginary. Remember, it has to be real, then imaginary. If you have a different order, it's incorrect. The calculator will also do the FOIL rather, like this one, -3 plus 2i times 4 plus I. But again, put them both in parentheses. You don't have to hit times in between. -14 plus 5i. Now for this one, the W is on top. So this is 4 plus I on the top. That needs to be in parentheses for sure. The division is super, super picky. I would be careful and make sure everything is in parentheses. Your calculator gives you a decimal. Please switch it to a fraction, and then make sure you can read your calculator correctly. It has a common denominator of 13, and then we do -10 minus 11i. Some of your calculators look like this, and the I is at the end, and making it look like the I is in the denominator. That's, of course, never, ever true. So make sure that you can read your calculator correctly. Dot product. If the dot product is 0, then yes, it's orthogonal. If it's anything else, then no, it's not orthogonal. Orthogonal is a fancy way of saying perpendicular. So we have -5 times 3 plus the y is -8 times 2. So we get -15 plus -16, which is -31. Please give the answer, and then no, this is not orthogonal. So the dot product here, -3 times 36 plus 18 times 6. You can just put this in the calculator. I'm just writing it out to show you what the numbers are that we multiply. Okay, sorry. Awesome. Can't erase it now. Oh well. So we have -108 and then +108, which is of course 0. And if it's 0, then yes, it's orthogonal. For the angle between the two vectors, I will give you this formula. This is the only formula you will get. So make sure you know magnitude, direction, putting it back into component form, and dot product. So be careful with how you do this. Do as much as you need to get this simplified. I always write it out just out of habit. So the dot product is on the top, and then the magnitudes are on the bottom. They get multiplied together. So magnitude of vector x would be 7 squared and 7 squared, multiplied by the magnitude of vector y, which is 2 squared and 9 squared. So the number on the top is 49, right? -14 plus, yep, so 49. And the number on the bottom is the square root. You can just multiply all these together, and the square root will be just a single radical sign, 8330. So it's up to you. Are you going to put the fraction in first and then do second cosine, second answer, or are you going to do second cosine of that fraction? Either way, you do need to make sure you use the inverse cosine key. So that's second and then cosine. It doesn't say what to round to, so we'll go to 2 decimal places. We don't really know what quadrant this is in, so we just trust the calculator and we write down what it says, 57.53 degrees, which is why if you're not putting this in the calculator correctly, you won't know. You really won't. All right, let's try this one more time. There is only one of these on the test. So again, it's the dot product on the top. So 8 times 4 plus 5 times 0. And then it's the two magnitudes on the bottom. The square root of 8 squared plus 5 squared times the square root of 4 squared plus 0 squared. So the numerator is 32, and the denominator, this is the square root of 89 and the square root of 16. So we multiply those two things together and we get the square root of 1424. So I put this in the calculator. I always do the fraction first and then the second cosine of that. We get, it's almost an exact answer. So we'll call this 32.0, gosh, 1 degrees, I guess. So again, make sure you can get those numbers from your calculator. And this is the only formula you get.